spoke to the dark and fleshed out the wonder of life. And as you speak, 100 billion galaxies are born. In the vapor of your breath, the planets form. If the stars were made to worship so light, I can see your heart in everything you've made. Every burning star, a signal fire of grace. If creation sings your praises so loud, so God of your promise, you don't speak in vain, no syllable empty or void. For once you have spoken, nature and science follow the sound of your voice. And as you speak, 100 billion creatures catch your breath, evolving in pursuit of what you say. If it all reveals to nature so alive, I can see your heart in everything you say.
Hello, everyone. Y'all heard Esther over there whispering into the mic, not knowing that we just went live, but that is part of Wise Youth Unplugged, my beautiful people.
Yes.
Welcome to Wise Youth Unplugged. This is where the youth get together and, we try to explain things that we understand in our way to explain to other youth, the easier way to understand a couple of things or certain things. I have a special guest here, Esther Santana.
Hello.
You're a round of applause.
Yes, thank you. I am back after many months. I retired a little bit, then came out of retirement.
Retired. Wow. But I'm very excited to have her. She says that she's not nervous. I'm nervous, and she says that she's not nervous. So that is a shocking moment. That is a shocker, and I'm, actually impressed that she's not nervous. But I'm over here just shaking in my pants. But it's okay. We have a very interesting topic for you all today. Very interesting. So interesting that I don't even know how I'm going to explain or express myself. But the Lord He will enlighten us and He will help us get through it.
Yes.
A lot of information, y'all. But I want to explain how I understand things so that we can all, understand it in a different way. Of course, we're going to be talking about reproductive seeds. That is the topic that we are talking about in Wise Youth Unplugged for this whole month. So every time that you all see someone new coming in, or not someone new, this week is Girls Talk. Next time y'all probably see Boys Talk or Pastor Hedwig or Pastor Adriana. We're all going to be talking about the same thing, but just in different perspectives and how we, can understand the material that we're going on, that we're talking about in church. So let's get started. Go ahead, Esther. Esther is going to be reading some verses, and we'll start from there. But first, I forgot, y'all. Of course, if you have not already subscribed to our YouTube channel, go ahead and click on the little bell. Subscribe to Wise Youth Ministry, and you will get notifications every time we go live, or notifications every time we upload something. Of course, we have our social media accounts. So we have Facebook, Instagram, and YouTube. So go ahead and like all of those pages so you can also get notifications. And we have a very special event next week. very special event next week, which is Champions Conference. So if you haven't already gotten your ticket for Champions Conference, go on our website, www.wiseyouthministry.com, and there you can get your ticket for free, okay? Event begins at 7:00 p.m., so please invite your friends, your family, other people from different churches, and we will have a wonderful time that day. So if you haven't already, go ahead and do that, and we will get started.
Yes. So today we'll be reading in Genesis 3, verse 6. I'm going to give you a couple of seconds to get there if you want to. Or if you...
I need those seconds. All right, go ahead.
Okay. So it says, so when the woman saw that the tree was good for food, and that it was pleasant to the eyes, and a tree desirable to make one wise, she took of its fruit and ate. She also gave to her husband with her, and he ate. So from this verse, we were talking about in the preaching about what it meant when they said that. So technically the woman is obviously Eve, because we're in Genesis, and her husband was Adam.
Okay.
And I don't know how I should explain this, but in the Garden of Eden, no one actually reproduced the way they do it now. It's all by words, because that's how God did it. Like he formed things, he created things with the words. So when it said that she gave to her husband, they probably talked. But the food that they're talking about there is not an actual tree. It's not what everyone calls the tree of life or the tree of good and evil. It's not actually that, but it's actually a counselor, as we have learned in our preachings. And the counselor is El Barón Lucifer.
I'm done with you.
So the way that she, ate of the tree was when she decided to disobey God's commandment, and she actually spoke with him and saw that it was desirable to the eyes. So that's the way that she did that. And when she gave to her husband, Adam, he obviously, so she was already, had the child, right? Mm-hmm. Because that's the way that they did it, through the words. Mm-hmm. And then when she gave to her husband, Adam, she also received the other seed.
Okay.
And so you might think to yourself, man, why was Cain and Abel so different?
Right.
It's because, get this, the fathers were different. And now Kathleen here will explain that to you, because obviously I don't know too much about science now.
Right. So Esther gave us a wonderful explanation of how we're going. This is the introduction of what we're going to go into. I have a lot of material that we're going to be covering, but I have to explain it in order for us to really understand. So like Esther said, why the question of today, the question that we need to keep in our minds are, why were Cain and Abel so different, right?
Mm-hmm.
Why were they so different? So you all know that we've been talking about DNA, we've been talking about chromosomes, we've been talking about all of these different things. And so I'm going to give you all 5 keywords that we're going to be talking about today, and I'm going to try to do it fast because we don't have that much time, but hopefully you all will understand what I'm trying to say. So the 5 words that we're going to be talking about is, of course, DNA. We're going to be talking about chromosomes. We're going to be talking about genes. We're going to be talking about alleles, however the people say it. And then we're going to be talking about traits, right? So let us begin with DNA, of course. I'm going to put up this picture so that we can understand and follow the picture of how these structures go. So the first one, which I think, and I found it, and it's really easy to picture and to see. So here in this picture, we see a cell, which is what our body is composed of, many cells. Mm-hmm. Inside of each cell, of course, there's a nucleus, okay? The nucleus contains the chromosomes, which is the DNA basically packed all together into that chromosome. And then our chromosomes, of course, they contain the DNA and they contain the gene. Okay? You good there?
Yeah.
I'm trying to slow it down so that we can all, understand what we're covering today. So the important thing about our DNA is that we all have it. We all have different DNA, of course. It's all composed. We're not going to have it, but it's possible. So that's all in the DNA. So also DNA, it tells it tells a specific piece of us. So that's why when you see the CSI movies or those movies with forensics, they always have to look at somebody's DNA to understand what that person's body. So let's say we're looking at a dead body. They take what? They take a piece of hair, they take a piece of skin or nails, and that's how they determine, okay, this is this person because their DNA is on this body. So that's that. So that's where, the forensics part of DNA comes in. Forensics, they use a lot of DNA stuff. And so the amount of our DNA bases and the sequence of those bases is what determines how different we're going to be. Okay. So everyone doesn't have the same sequence of DNA. Every base is different. We all know A goes to T and C goes to G. We've learned all of this with Pastor, y'all, so I'm not going to explain all of that. So, but that's part of what makes up our DNA. And I'm going to put another picture so we can understand, because, we're about understanding today, and I got pictures.
Yes, the goods.
Cell, nucleus, chromosome, DNA, gene, trait, allele. Those are all of the things we're going to be talking about today, my people. And if you look at the gene on that bottom piece, that's where all of the bases connect. So A to T and C to G. Perfect.
Yeah.
Okay, so that is it for our DNA segment. Did you understand, Esther? I want to know if you understood. Because if you understood, then all other people understood.
I was getting there. I mean, yeah.
Okay, we're gonna continue to explain.
I understood most of it. The A to T, the C to G, that sequence, and I understood kind of.
All right, we're gonna keep going. So
I am also learning, guys.
Yeah. So the next thing we're gonna move on to chromosomes, which I told y'all in that picture. So the chromosome is that little figure that y'all see with the 4. I don't even know how to explain it. With the 4, it's like a little X in the middle. Y'all know what I'm talking about. So that is the chromosome. Our chromosomes are structures where the DNA are tightly packed. So that long piece of double-stranded DNA is all tightly compacted into the chromosome. So instead of it being long, it'll be really, really tight, but it'll fit into that chromosome. And each of us have 46 chromosomes in total, right? We get 23 from our mother, and of course,
23 from our father.
And 23, I'm trying to switch cameras, y'all. It's a lot going on. And of course, 23 from our father, okay? So how many chromosomes we got?
46.
46, and we get 23 from who?
Our mother.
And 23 from who?
Our father.
Our father! Look at us learning, y'all. Look at us learning. So that is all for chromosomes, because I'm trying to explain everything quickly so that we can get to the point where we understand why Cain and Abel were so different. So let's keep going. So let me put the picture up again, because we're going to be using this picture a lot. Next, we're going to be talking about the genes. So you all we see chromosome, we see DNA, which is the long double-stranded, and then we see gene, which is just a portion of the DNA. So the gene is just the portion of the DNA, and these are expressed as proteins, and proteins play a role in expressing our trait. I know you learned about what a trait is. What is a trait, Esther?
A trait is
What is a trait? What is your unique trait?
I can't specifically put the words to it. But a trait is something you inherit from your parents. Let's just say that you're, I don't know.
What do you inherit? Something that you have that you inherited from your mother?
Being silly, I guess.
Being silly, okay. So that could be a trait. And I'm just going to give the definition of a trait, which is a distinguishing quality or characteristic of a person.
Yeah.
So that's what our trait is. Boom, 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 boom. So now that we have that this is where the new information comes to y'all, because I'm pretty sure y'all haven't, learned about this. I've learned about this, and maybe other people have. It's really hard to explain, but I think out of, I'm in school for nursing, and I think this was the most interesting lecture or the most interesting class that we've ever gone. Well, in my opinion, this was the most interesting class that I've ever been in. And of course, it's about DNA, genetics, and all that stuff. And I think it sparked my interest even further of wanting to be in the medical field because of all of this that I learned. Like, it's amazing how the human body works. Like, nobody can sit here and tell me we came from a whole rock just hitting the earth and boom, we were created. No, that is impossible, because our body and the things that our body does is too complex for you to tell me that I came from the Big Bang Theory. Sorry.
Yes.
No. No. So that is one of the reasons why the medical field called my attention, because the body is just amazing. And so, I'm sharing a little bit of what I've learned in class, throughout the years. Let's get back to it. Just giving a little testimony.
Yes.
Adding testimonies so people know what you're talking about.
Add a salsa.
Right. So the next piece I want to talk about are, genes. I have another note here. Genes there are multiple sequences of the A's, the C's, the T's, and the G's, which is those bases that connect to make DNA. So they're just different sequences. And these help the genes make things such as our eye colors, if we have freckles, if we have our earlobes are stuck to our skin, or if it's, not, those things. So we're going to get to the alleles now, or the alleles. And I'm going to add a little picture because this is where it gets complicated. This is where it gets complicated.
It looks complicated.
It looks complicated. So each chromosome, of course, you all see the chromosome. Just pretend like the chromosomes are together, okay?
Yes.
Let me put the picture so you all understand. So we're looking at this picture here is the same as that picture with the chromosome on the top, that blue figure. It's the same thing, it's just one side and the other side, okay? So it's the same thing. One of these chromosomes are belonging to our father, and the other chromosome is belonging to our mother, right?
Yes.
So tell me what you see different up there with just the two figures, Esther. What is different with those two figures? The only thing that you see different.
That one has an A, the other one has a B.
No, just the top two. One has a uppercase A. You see it? Top two.
No.
Where it says chromosome allele 1 and allele 2. Right here. Oh, dang, I didn't even put it on the screen. Here.
Oh.
Where you see?
I couldn't see it from there. Yeah.
Okay, so with alleles, we see that they are one big A and one little a, right?
So taking a guess, the A is the dominant and the capital is the dominant and the lowercase is the recessive.
Okay, Esther is a little bit advanced, y'all. She over here trying to get through the lecture quickly.
No.
But we're gonna get to that. So let me put the picture back. So each chromosome has an allele or allele. An allele is one or two or more versions of a gene. Okay, and we all know what that gene is. Let me put the picture again, because we're gonna learn today. Gene. That gene is that little segment of DNA. So it's not DNA, it's little segments. So half of a DNA strand, right? That's what that is. Okay. So an individual inherits two alleles for each gene. So we have two alleles for each gene that we have, right? One from each parent. Okay. If the two alleles are different, if the two alleles are the same, the individual is a homozygous for that gene. So the homozygous, we all see the bottom four pictures, right? The two on the corner, so the one on the left-hand side and the one on the right-hand side are homozygous because they both have the same letter. Mm-hmm. So the homozygous has both of the uppercase A's, and both of the lowercase A's is the other one on the right side, right? And if the alleles are different, the individual is heterozygous. So we all see the middle, it has heterozygous because they both have A's, right?
Yeah.
But they don't have the same type of A. which is the uppercase A and the lowercase a. So those middle ones have that, right? So alleles are represented by letters. If there is a capital letter, that allele is a dominant trait. Okay, Esther, we see you getting ahead in the picture. And if there's a lowercase letter, that allele is recessive. Dominant alleles are always expressed. So if someone in, let's say if our father has a dominant trait, then that dominant trait will express in us. So we will be able to see that trait in something that we have. Now, if our mother has a recessive traits aren't really expressed. They're not usually expressed. Now, the only way that recessive traits are expressed is if there is no dominant trait, right? So if our father is dominant and our mother is recessive, we will get more features from what? Our father,
yeah,
right? Because our father is the one that has the dominant trait. Okay, back to the picture. So, recessive are not usually expressed unless there is no dominant trait. And so there are two allele copied within our genotype, okay? Our genotype is very interesting. And that's where we get to the next part, okay? Did you understand, Esther?
Yeah, I understood.
Tell the people that you understood or didn't understand.
I understood it because the heterozygous one is the one with the mixture. Okay. So, yeah, and the homo one is not. So that means that, sorry to interrupt you. That means that if you were in the hetero one, that you would obviously have, the dominant and the recessive, but the one that doesn't, it's just vibing. Because the lowercase a, that means you have more recessive trait, and the uppercase ones, that means you have more dominant.
So that is Esther's understanding of.
It's my explanation
of the lecture, right? But of course, we got to make this more understandable. So that's why I got pictures, because we're going to learn today.
Yes.
We're going to understand today, okay? So that is a more complex picture, but I have a better picture for us to understand, right? Okay, so let's move on to, let's do this picture. Okay, wonderful. So here we see that humans get 2 copies of each gene, and which is basically 1 copy from each parent, which is what we talked about with the alleles, right? Let me put this on the screen over here because I see Esther squinting.
Yeah, my eyes.
So, boom. The alleles, do you all see those little, these little squares where the arrow is coming out of?
Yeah.
And the little X's, those are chromosomes, but I'm going to say as little X's so you all can understand me. So the little X's, they have a little rectangle piece there, each of them, and they have arrows coming out of it. Those are the alleles, right? Oh. So the 2 copies don't have to be identical. Each variation of the gene is also called an allele, and alleles give us our diversity. So that's what makes us different, okay? So if you all look at the picture, you'll all see that one allele, the eye color is blue, and the other allele, the eye color is brown. So we're gonna just read this example. It says, for example, if a gene contains information for eye color, one allele might code for blue eyes, and another might code for brown eyes. Okay, so that is what our allele is giving us. So our alleles are basically responsible for what we get from our parents, right? And we're gonna use this picture here, since we're talking about eye colors.
Yes, easy to understand.
For us to be able to understand. See, I got examples we're gonna learn today. Okay, so we have BB, which is let's look on the brown. So we're looking at the brown eye. Dominant B, which is that uppercase B, and lowercase b is the recessive B. Just by looking at that, and just by what we understand from the dominant, who is that? Who are we looking at? Who has the brown eyes? The mother or the father?
The mother.
With what we understood with the brown eye, with what we understood with the dominant and the recessive.
Mm-hmm. The mom has the brown eyes. Yeah.
No, because she has the big B. I mean, he has the big B. Big B
Go
is
back
dominant.
to the picture so I can see it.
Big B is dominant, Esther. What picture? We gonna understand today.
Wasn't it I thought it was the mom with the brown eyes.
We'll explain this later, Esther. Okay, so the big B always is dominant, okay? So the big B always shows the dominant trait. So this is why the brown, the big B, and the little b would represent the father because he has the dominant trait. Now, it could be the other way around, but in most cases, the father is always the one that has the dominant trait, right? So that side, we have the father, and then the blue eyes, of course, it'll be the mother because she has the two lowercase b's, which represent the recessive trait, right? So this is called a Punnett square. And this just basically a square that shows us who's going to inherit what in what generation, right? So the four little squares on the inside just show the children. Let's say that. They show the children, okay? So in the case of the first child, we see that those two B's, the uppercase B and the lowercase b, are all connected into that one little square. So that's why we see that the first child or whatever child will come out with a uppercase B and a lowercase b, right? So that's a dominant and a recessive trait. The one beside it will come out with a uppercase B and a lowercase b, which is the same thing. So if they have that dominant trait from the father, then they're going to come out with whose eye color? The father's eye color.
The brown.
Right? And so the next piece is the double B, the two lowercase double B's, and they're going to come out with the eyes of the mother because, of course, if you all look it up, it lines up. The B on the top lines up with the B on the bottom. So, of course, that child is going to come out with a lowercase b. So that is that. Let me show you all another picture, which is maybe more understandable.
This is where we get back to Genesis 3:6.
Exactly. Okay, we're getting there, y'all. I'm just trying, to make it understandable for us to understand. And this is a chart. I remember we were going. Let me put the camera because y'all haven't seen my face. We were going through a lecture in class, and Pastor was talking about. I think he was talking about. Our genetics it was a while back. I think it was like a year or two ago. He was talking about genetics. And when my teacher put this on the screen, everything just clicked. And I think I sent this picture to Pastor. It was a while back. But, and it's always just stuck there. Like, it's just amazing how things are inherited. Yeah. So this is what this picture is basically showing. So let me see if I can explain it a little better. So we have two sides. So one side has an unaffected father, and the other side has an affected father. Let's just look on that first little side. Let's look on the left side. So if our mother is a carrier, okay, a carrier mother, that means that she has something in her blood that she's going to be able to pass on to her children, right? So of course, every child has a different probability of getting whatever it is that mother has, right? So that's why we have those 4 children. Let's say a probability 1 out of 4. We have those 4 children. With an unaffected father, let me try to tie it in together. With an unaffected father, we have, let's say this is who?
What does it mean, to have an unaffected father?
Okay, so an unaffected father, let's say, that's what I'm trying to put something together so that we can understand it. An unaffected father will basically mean that the father doesn't have any type of disease. Let's say that.
Okay.
He's unaffected.
So she has the disease.
And so the carrier mother, let's say that she has the
Eve.
I'm trying, to explain, y'all.
She got that disease.
So that's basically what that means. So the unaffected father doesn't have a disease. The carrier mother has a disease, right? So when they both mix, and we all know what mix means, when they mix, they're going to have children, of course. So if these people have children, every child is going to come out different because of that mixture that's happening. So with the carrier mother, of course, out of 4 children, there's going to be 1 child that is going to have what she has. Right?
Yeah.
Out of 4 children, there's going to be a son that is going to be affected with whatever she has, right?
Mm-hmm.
And then, of course, there could be 2 other children or 1 other child that doesn't come out with anything, right? All of this to explain. Ha ha, ha ha, ha ha. let's look at this one. Let me go back to this one. So with our alleles, of course, we just learned that whatever allele we have, whichever one is more dominant. So if our father has a more dominant trait, then that is what we're get. Or if our mother has that dominant trait, that's what we're gonna get. So in this case, a cleft chin is an example of a dominant gene. So if our father has a cleft chin, and you all see the picture up there, if he has a cleft chin, then there's a high probability that maybe one of his children will have that cleft lip, right? Mm-hmm. The same thing with the dimples. Everything runs in the family. If somebody has the dominant trait of dimples, then there's a high probability that you're gonna have dimples. The same thing with the hair color. If there's somebody that has a dominant trait of that exact hair color, then there's a high probability that the children will come out with that hair color, right? Okay, and it goes on. So the eye color goes with the earlobes, it goes with the freckles, it goes with all of that. And then I have another one here, just a different chart. The tongue, the curly hair, the straight hair, the straight thumb, the curved thumb, all of that. I hope I am explaining myself good. Okay? All of this to get to the moment of truth.
I feel like that first part is what we're talking about. We could throw out the other side.
She said throw out the other side.
Because the carrier mother, I believe you all know who it is. Haha.
So all of that to say, my understanding and my interpretation of what happened in Genesis 3:6.
Yes.
With why Cain and Abel are so different. Let's go back to that chart. Okay? The carrier mother is Eve.
Yes. Say louder.
The carrier mother is Eve, okay? She is carrying
the virus, guys.
The virus, right? She is carrying the virus. Now, Esther, I want you to read Genesis 3:6 again.
Okay.
I want you to read that again.
Let me get it here. So when the woman saw that the tree was good for food, that it was pleasant to the eyes, and a tree desirable to make one wise, she took of its fruit and ate. She also...
She took of the fruit and ate. That means she became contaminated.
Yes.
With what the fruit is. We're not going to get to that explanation of what the fruit is because
you have to come to the next program,
right.
Guys.
Come to the next program. Come to Sunday services so you can understand.
Leave a little bit of mystery there.
Right. But we understand that Eve has just become contaminated by eating the fruit, right? She has become contaminated. So whatever she has just put inside is what is inside of her. Okay? Keep going, Esther.
She also gave to her husband with her, and he ate.
So she gave to her husband. So now we have not one person contaminated, but we have two people contaminated.
We have a whole generation. What are you talking about?
Right? We have two people contaminated. Now, the graph, of course, it says the unaffected father. But we're gonna just, he's not the carrier, so he's not unaffected. The one that's carrying the whole weight, if that's understandable.
It's just the children that really get the contamination.
Exactly. So now when you add the unaffected father, which is not necessarily carrying the virus, but he has taken part of the contamination. Mm-hmm. This is when the children come out. Mm-hmm. The children come out. Let's look at those on the bottom of them. We have one child that's going to come out with the carrier, and the other child is going to come out affected because, of course, that mixture of those two come together and make children. Haha. So this is all I've been trying to explain, my people. This is it.
So guys, who do you think was Cain? Was he the unaffected son or the affected son? Haha.
Yeah, I have. This is interesting, but so that's all I've basically been trying to explain. So how we get how we get passed down the things from our parents. is what I'm trying to explain, okay? So that was just a way that I understood why they came out so different. So in my interpretation, Cain came out with of course we know that they have two fathers, right?
Mm-hmm.
Cain came out as the evil son, right?
Yes.
Which means that he has the dominant trait, and I just explained what dominant trait is. He has the dominant trait of who?
Of his father. Lucy.
Which is Lucifer. And then Abel came out with the dominant trait of who?
Adam.
His father. Okay?
Yes.
So that's why they came out so different. That's why Cain came out so, mischievous. We're going to say mischievous. And Abel came out with the character, we're going to say, of heaven. Okay? And Cain with the character of not so heaven.
Yes.
So all of that was to explain my interpretation, how I, with my knowledge and my studies, how I interpreted the whole passing down, generation from generation. They came from the same mother and father. Of course, they
came from the same mother.
From the same mother. They came from the same mother, but they came out so different. And this is why we have, I haven't had children, but people have children and their children come out so different because there's different dominant traits that are expressed in one, different recessive traits, different genes, it's a lot that goes into that, y'all. Yes. But I hope that I, made you all understand this a little bit. And of course, I understand that we're not going to understand all of this in how long we've been here? In about minutes.
Yeah.
30. Of course, we're not going to understand all that in 30 minutes, but I just hope that my explanation kind of, helped us understand just a little bit. And I think that is all for today's program.
I'm not so knowledgeable, but I heard that, a woman, she can get, the seed, and a couple of days after, another seed can enter the womb. I believe that's how it went. She had two seeds in there because she had twins also.
Okay. So you believe she had twins?
She had twins. Adam, Cain and Abel were twins.
Okay, Esther. That girl Esther over there doing her research. Anyways, we're not going to get into all of that.
Yeah.
There's a lot of info.
We'll just do it for the boys' talk.
Right. We're waiting for the boys' talk. Let's see if they can top us. I'm just like, it's not a competition, my people.
It is a competition.
So that is all for today's program. Like I said, I hope this made you all understand just a little bit more. That was my revelation of what I understood from everything that we're talking about. And I wanted to bring all of this for us to understand how heredity works, because that's heredity. What we inherit from our mother and our father, and how we get the things that we get, how we get our eye color, how we get our hair color, how we get all of those things. And of course, it doesn't necessarily have to do with physical features, because of course it has to do with the way that we act. The things that we do are where we get our, let's say if you're dealing with anger, you probably got that from one of your, one of your parents. Different diseases, all of that comes from heredity, everything that is passed on. So all of that. So I hope that you all understood. Please leave a comment, like this video. And Esther will lead us out in prayer.
Don't forget to also share the video, guys, and to sign up for conference in case you weren't here at the beginning.
Yes.
Thank you, God, for this day. Thank you for the blessing of today. Thank you, God, that these people were able to connect with us, God. And I hope that they grasped what we were trying to say, Father God, and that their spirit received it. I pray that you help them, God, to continue to understand and do their own research, God, to really look forward and to dive into your word, God. Thank you so much for what you do, Father God. Thank you for the life of Kathleen. And thank you just for everything you do. In Jesus' name, amen.
Amen.
And as you speak, You creatures catch your breath, evolving in pursuit of what you say. If it all reveals to nature so alive by your grace, if creation still obeys you so